Hello everyone, welcome to the new video. Today we are going to make an incubator in which we are going to use very commonly find things like a plywood, a metal container, a 100 watt bulb. So here you can see I have bought some plywood cuttings from the carpenter. You can see it has a different sizes, but I managed to cut into the size which I wanted. So in further video I will show you how we can make the incubator for laboratory or incubator for an egg hatching, or you can use this incubator just to keep your food hot and warm. So these are the size of the woods which I needed, but it can depend on how you want to make and what are the sizes and what are the your requirements. So let's just see. This is the 100 watt bulb which I am going to use. So also it will need a holder. So this is the holders. So one of them I will use. You can use any one of them. And you can see this is the temperature controlling module W1209. It comes in around a price of 150 rupees, and this is a 12 volt adapter. You can use any transformer adapter or anything which can supply minimum of 12 volt 1 amp. So you can see how I attach external wires on the push buttons so that it's easy to control the temperature from outside. So these are the push buttons. I connected it because if you place display like this, you can see there is so much gap that we can't put exact holes, so we can't access the push buttons. And this is the tin container which we are going to use. So you can see I have made a hole for holder and two hole for tightening the screws. So let's just see how the container which is made from wood looks like. And here is the holder which I was talking about. So you can see how I fixed it. This is the screwable holder. You can remove it and replace it in the future if you needed. And here is how I fixed it. So it is used with baking soda and super glue. This combination works so good that it won't come out easily. So you can put the holder back like this and you can replace in future if needed. So the container will go on top of this like this, so it matches the perfect holes. And now you will see the front panel I have made. This is how it looks. I will use some screws from top side to fix it, because if it get damaged in the future we can replace it, because if we put nails or use any glue to put the panel, it's not possible for us to remove it unless it's breaked. So you can see how it looks when placed. So it's looking really nice. So what we'll do is uh, do some wiring before we put the panel. This is how the wiring is done. The wiring is not shown here, but you will find the circuit diagram in this video only, so keep watching. So we will put screws and tight the front panel. So how it's looking, you can see this is looking really nice for now, but we will also color it in further video. So before that we can fix this 12 volt module here. If we kept it like hanging, it will make noise and can also short circuit inside. So I have made this holder for it, so it will stay at its place, and this is how it looks, and it won't move ever again. And here is the hole which is for sensor. The sensor wire comes out from this side and will go into the tin container, so it can measure the temperature inside the container, so it can turn the bulb on and off. So this is the container, and I have used this cardboard and some aluminum foil on it with the help of Fevicol or any glue you want, and this will go like here. I have sticked all of the panels, but the bottom one is not stick yet because we need to screw it on this holder. So after that we can screw this like this and add that insulation panel, so the screws will get hide inside this. You can see these are the screws I am talking about. So after this I will add the panel of insulation which I showed you earlier. So let's just put it the way I will show you how it's going to be here. So this is how it looks, and we will make a hole so that the holder is open and we can put the bulb like this. You can see how nice it looks. And this is the sensor. It goes from back side like this. You can remove it or you can just fix it with the help of sellotape. So it's a temporary or a permanent solution for it. So this is how it looks. So what we will do is, now I will add a 3-pin cable because this cable is needed to supply the power, the AC outlet. It gets connected to the AC outlet and goes into the our incubator. So this is the earth wire, green wire is not used, and these are the live and neutral wires. And also you can see here are the zip tie used, so that if it gets mistakenly pulled back, it won't come out. So on the bottom side I have added another wood panel, so it's closed now and we can use it. But before that, let's just color it. Here is the circuit diagram. You can see how it's wired. So I am planning to use two colors. Before that we will add a sellotape like this so that buttons don't get colored. And here are the color I am going to use. This orange color will go on the wood side and this green will go on the metal box. But unfortunately the orange color was expired. I saw it after painting, because when I was painting it with the spray, the color was not sticking and was just flowing down. So I just colored the whole thing in green. But soon I found that the front panel is looking really dirty. So I planned a new thing, which is to create a design so that it will have our YouTube channel's name and a product name. And this is how I am going to mark the holes and cut it. And you can see after arranging it all back, this is how it looks. It looks really nice. Here is the incubator name and our channel's name. So here it is the. So let's just have a look. Let's turn it on, and here you can see the bulb is also lit up. It will heat the box and the sensor will read the temperature and turn on and off according to it. So let's just close it and let's do a little test. You can see I have a temperature module which measures the temperature. Current temperature is 25 degrees Celsius, and this bottle contains cold water. Actually I kept both the bottles in refrigerator for an hour, so the temperature should be same. But you can see here is the 18.6 degrees Celsius, and the temperature in this yellow bottle should be same. But I realized that the temperature is a little bit high, like 19.3 degrees Celsius. So it's okay, just we are going to test the temperature difference. So here is the room temperature 25 degrees Celsius because it's cold here. And now we will put one of this bottle inside the incubator and keep one bottle outside, so we can analyze the temperature difference after heating it. So let's just put this inside for 2 minutes. I started a timer of 2 minutes in my mobile and kept it inside this incubator for 2 minutes, and you can see the temperature is at 37 degrees Celsius inside the incubator. So it goes to 37 degrees Celsius and turns off the bulb. When temperature goes down, it again turns on the bulb. So these cycles go on forever until we want. So the temperature is maintained. So let's just open the incubator and see the temperature difference. So this is the bottle we kept inside the incubator. So we will measure the temperature of this. So the temperature in this bottle should increase, and you can see, I will fast forward the video. It shows 27.7 degrees Celsius, and we will see the temperature of the bottle which we just kept outside hanging around. So you can see, I put a probe here, and the temperature is going down because it's still cold and we want to increase the temperature. So what we will do is, now I will put 5-minute timer and add this bottle again back to the incubator. So the same bottle will go back inside the incubator, and we will do more 5-minute test. So video is fast forwarded, and after 5 minutes I will open this and show you the temperature difference I found. So first of all, let's just see the temperature of the bottle which was kept outside. So let's fast forward, and it's 24 degrees Celsius. So it's still cold, and now we will see the temperature of the bottle which was kept inside. So let's just put it inside this, and also I will fast forward the video so we can save a little bit of time. So you can see the temperature is 33.4 degrees Celsius. So absolutely it's working fine, and the temperature change you can see in real. So you can use this in the laboratory for maintaining the temperature of particular reagents and anything you want, or you can use this as egg incubator. Or the better thing I found is that to keep your hot food inside.